Welcome to the webinar on mastering the workflow of road design with Plateia. My name is Gregor Pipan and I'm joined by my colleague Petra Tihole. And we're both excited to have you here and hope you enjoyed the webinar. First, let me share with you some technical information regarding the webinar. So the session is being recorded and it will be shared with you later on after the webinar. And you're all welcome to ask questions. For this purpose, you can find a section in the webinar dashboard. It is called questions or comments, and just please type your questions there and we'll try to answer them at the end of the webinar so that we don't disturb the flow of the webinar, or if there are some questions that can't be answered immediately, we will prepare an answer and send it to you by email. There are many of you who don't know us yet, so let me first shortly present our company and our products. So CGS Labs is a software company that is from its very beginnings engaged in the digitalization of the built and natural environment. We now have more than 30 years of experience in this field, and we are active globally as an international software company. We have our own offices in Germany, Czech Republic, Serbia, and of course head office in Slovenia. But we also have a worldwide network of partners. So we're a long-time partner with both Autodesk and Bricscat, and all our software, of course, runs on both platforms. But in later years, we're also involved in development of BIM software solutions, and we promote the open BIM approach. And we're very active in international organization of Building Smart. We're also members of chapters in Germany and in Slovenia, and we contribute to development of standards for infrastructure design. So if we go to our software portfolio, with our CGS Labs civil solutions, we cover three main civil engineering fields. These are roads, railways, and river engineering. And today we will focus mostly on software solution for road infrastructure design, maintenance, and transportation. In this department, we have our main software, Plateia, and then we have also two other applications, AutoSign for traffic signs and road markings, and AutoPath for swept path analysis. Then in the railway department, we have software Ferrovia, which is a BIM software solution for railway infrastructure design and rail track maintenance. And then for in the river and channel department, we have Aquaterra, which is a BIM-ready software solution for channel and river engineering design. It can be also used for flood protection design and so on. But today we will focus mostly on our main software, Plateia, which is BIM software solution for road design and road reconstruction design. Plateia is a complete solution for roadway design. This means that it can be used for all aspects of road design, and it supports BIM workflows and processes. It has an intuitive user interface. It was developed by civil engineers, so it's consistent with the road design engineering practice, and we have feedback from our customer that this is what makes Plateia really easy to use and quite fast to learn. Plateia is a software for all design stages, from preliminary design to the final production of the documentation for the construction. you can use the software for practically all types of projects, from small roads, city roads to highways. Maybe an important information that the software is available in different packages depending on the functionality, but there is also various types of licenses available that provide you with the added flexibility. So after this short general introduction, I would like to hand you over to my experienced colleague Petra Tihole, who will demonstrate to you the road design workflow of Plateia in practice. Petra Tihole is one of most experienced engineers. She's working on CAD and BIM projects, and also cooperates with customers on the project. So Petra, please take over.
Okay, thank you, Gregor, for this introduction. And hello to everyone. I hope you are all having a great day. So my name is Petra and I'm a technical support engineer at CGS Labs. I'm very delighted to have you join me in this webinar, and today we will look together at the workflow of designing a road in the Plateia software. As Plateia is a complete road design software solution utilized for everything from simple visibility studies to complex BIM models, we will cover the typical workflow today. However, we will take a more detailed look at the creation and editing of cross-sections, as they form the basis for quantity takeoff reports and the creation of 3D models. Finally, I will quickly show you how to design the reconstruction of the road in Plateia software. I will do my best so that those of you who meet the Plateia program for the first time will gain valuable insights into the workflow of designing roads. In addition, I will try to also make the webinar interesting for those who have been using Plateia for several years, because I will add new functionalities and show you some tips and tricks that can make your work easier and faster. Well, let's get started. In the most typical road designing, we usually start with the preparation of the terrain. So CGS Labs software solutions offer many different options for creating terrain. The user can work with AutoCAD Civil 3D, BricsCAD, and CGS Labs surfaces, point clouds, and also project directly to native 3D faces. And also to CGS Labs points. In short, no limits. The only important thing is to be aware of which platform you have the Plateia program installed on. So the platforms we support are Autodesk AutoCAD, Autodesk Civil 3D, and BricsCAD. And if you have CGS Labs software installed on Civil 3D, in this case, you cannot project to BricsCAD surface and vice versa. As I already mentioned, designer also use point clouds. The process of creating a surface from a point cloud is slightly different when using Autodesk Civil 3D compared to BricsCAD. So we have prepared 2 tutorials on our knowledge base. So if you are interested, please scan this QR code and download the instructions. On the CGS Labs knowledge base, you can also find other tutorials, both simple and complex. In addition to the possibilities I have just mentioned, last year we also developed a functionality called external reference surfaces. This feature enables you to drape alignments, points, polylines, and other entities supported by CGS Lab software solutions onto surfaces that are stored in external DWG files. This preserves a small amount of data in the design drawing and thus provides better manageability, faster drawing manipulation, and production of smaller final drawings with all necessary design elements, such as the profile, cross-sections, polyline projected to surfaces, and more. So in the new drawing, I will first insert points from the XYZ file, based on which I will then create the terrain. So first, you click on the Layout tab and run the input points from file command. It opens a new dialog box where you define the file with points and set which data should be imported into the drawing. So on top of the dialog box, you click the folder icon and find the file with points. You select it, press open, and then click on the pencil icon, which opens a new dialog where you set which columns contain which data. Okay, you press plus button and you define a file type name. Okay. In this case, just an example. Okay, and then define the extension and select delimiter from the drop-down menu. Then it is necessary to define which column in the XYZ file represents which data. So on the screen, you can now also see the XYZ file opened in Notepad. You can see that in the first column, there is information about X coordinate, in the second column about the Y coordinate, and there is a column with information about the elevation. Then you define the point type. Since we don't have this information in the XYZ file, I choose option constant. So from the first drop-down menu, and then I select so that the program will, then I select the point type. And you also have an option to create your own point type with your custom attributes. Okay, then you can define the point type name. In our case, we will choose the option for the program to number the points itself, and alternatively, I can select the no data option, and the command will still insert the points in the drawing, but the name of all points will be 0. So we have no information on the other attributes, so we select the no data option. Then I confirm parameters by clicking OK. I select newly defined file type name from the drop-down menu, and if I have defined everything correctly, the data from the file will automatically display in the table. If you want the points to be drawn on a special layer, check the box at the select layer and type a new name. Okay, so here check the box and type the name, and you also have an option to select a predefined layer from the drop-down menu. Then you specify decimal places and then uncheck the box at the draw links option. Press OK. Points are now inserted in the drawing, and since these are CGS Labs points, we could already project alignment onto it, but we will also quickly create a digital terrain model. Okay, so I run the terrain command and define the surface name. And since the input data in the drawing is elevation points, you select point and break lines option from the drop-down menu, and then click plus button to select all points in the drawing and press enter. Next, you need to choose how to display the terrain in the drawing. There are several different ways available. If you do not select any options and confirm by clicking OK, the drawing won't change, but the software will remember the terrain and use it to draw the profile and cross sections. So in fact, this means that we have a terrain in the drawing, but it is hidden. To show the terrain as a triangulated irregular network, click again on the terrain icon, check the triangles box at the bottom and press OK. Okay, to make it easier for us to draw the alignment, let's insert a raster image of the map. So first, click the Utility tab and then run the Google Maps import command. Next, click the icon at the top right to zoom into the coordinate values defined by the center of your current CAD drawing view. After that, select the coordinate system. Okay, and then only check the box at the import raster option. and click import. Okay, so this way you can quickly insert a raster image or even terrain that you can use for a conceptual design. Now we will quickly draw the alignment, but before we start, we need to first define the axis in the alignment manager. So you run the alignment manager and define alignment name, and then check the box next to the drape to surface option and select the terrain. And okay, after you click the OK button, a new dialog box will open. In this dialog box, you can click on the category and then define the function of the road. And based on these values, the program will then warn you if you are not compliant with the standard. However, even if you do not specify this, you can continue designing as usual. Then you double click on the lanes. Here you can specify the number and width by double clicking on the lane. I would like to point out one thing here. So if you select the yes option, widenings will be calculated on this traffic lane. If you select the no option, the length of the traffic lane will remain constant along the entire axis. For example, we would choose the no option in the case of a sidewalk. You can also change lanes later, but then you will have to run one more command to refresh the lanes. Okay, so now that we have defined all the parameters for the axis, we can really start drawing the alignment. Okay, so to draw the alignment in Plateia, you have a number of options. For example, you can draw it with tangent polygon, floating elements, stick method, best fit analysis for reconstructions, and more. But due to time constraints, today we will only show you the tangent polygon option. So confirm by pressing OK and define the first tangent polygon point and continue with drawing this alignment. Okay, and when you have finished, you can press enter. Okay, and then you can also use the tools from the alignment section and to edit the alignment anytime. For example, you can select the move option, and then you can move the location of a specific vertex of the alignment directly in the drawing. Okay. And or you can run edit alignment in tangent polygon command, and for example you can change some parameters manually. So in this case I run the edit alignment in tangent polygon and then manually change the value. After drawing the alignment, you usually draw sample lines, but you can draw these lines later before making the cross sections. So you run the draw sample lines command, and in this dialog box, you specify the parameters. And after you specify all the parameters, you simply press OK. And the result is the alignment with sample lines all draped on the surface. And after that, we continue with the profile. So first, you run the draw profile view command. You set the parameters and confirm by pressing OK and define the insertion point in the drawing. Okay, and then we use the profile tool to draw a vertical alignment. So right now, I will run the profile tool. And select the first tangent point in the drawing, and then continue by clicking off vertex points by means of a mouse. And when you have finished, you can simply press enter. And yeah, just like alignment, you also have a number of tools with which you can edit the drawing profile. For example, you can move the profile, and there is also a command for editing the vertical curves. Okay. Next, you can calculate superelevations. In this dialog box, you define the superelevation type and other parameters, and then confirm with OK. And superelevations will be calculated and drawn in the profile table. Today, we will not study the superelevations in more detail. So if you are interested, you can read more about the editing options on our knowledge website. But before we continue to cross sections, I can quickly show you how easily you can calculate the volume between two surfaces. In our example, we can calculate between the top surface and terrain. This command is very convenient for quick calculations, especially for calculating cuts and fills once you have embankments in your drawing. So first, we draw the 3D polylines of the road edges. Okay. Then we draw a surface between these 3D polylines. Okay. And after that, we go to the site design tab. And we find the surface command, surface volume command. And after starting the command, you select the first, then the second terrain. And after that, the values are displayed in the command line. So I hope that this volume calculation command will come in handy for your projects, but now let's continue designing our road. So the next step is to create cross sections. So first we run the draw cross section view command, then define parameters, press OK, and then define the insertion point and of cross sections. And yeah, this command creates cross sections and insert terrain lines and roadways. So, okay, after that, we will insert a typical cross-section elements, so including pavements, curbs, sidewalks, shoulders, and more. However, if we want to create a quantity takeoff report and draw a 3D model based on the cross sections, we have to planimetrify these elements. So those of you who are seeing Plateia for the first time today may wonder what this planimetry quantity is. So essentially, it is a hedge that can be used to create a quantity takeoff report and draw a 3D model. For example, the planimetric quantity representing humus is marked in blue. This planimetric quantity is drawn in the first cross section and then also in the second one. And Plateia draws the 3D model by connecting the planimetric quantities between cross sections. The advantage of this approach is that it allows us to upgrade older 2D drawings to 3D models without having to start planning from the scratch. So let's go back to the drawing and look together at the process of drawing typical cross-section elements. So first we will draw a pavement. In the typical cross-section elements tab, I select a pavement and I click the tick button to draw the pavement element in all cross sections. Then I define the element name, thickness, slope, and distance. Below, we also have the option to choose the material. This means that the planimetric quantity will be automatically drawn in the drawing. I select asphalt from the drop-down menu, and then I click OK. Finally, I click on the lanes that represent the roadway and press Enter. Okay, the next element will be curb. So to begin, we start the insert block command and select the block from the drop-down menu. Any custom-made block can be inserted. Next, I check the box for the explode option and define on which layer it should be drawn. After that, I select the element to which the block will be attached. These blocks are not automatically planimetrified, so we have to planimetry them manually. And once again, these planimetry quantities are important if we want to have the quantity takeoff report and a 3D model of the road. So we run the planimetry command, and at the top of the dialog box, click the tick button to so that the planimetry will be carried out in all cross sections, and then we select the type of planimetry quantity. I select the area, and there are also two other options. The length is used for materials such as geosynthetics, geocomposites, geogrids, while thickness is used for humus, incut, or fill. If you are interested in more detailed explanation, you can watch our latest webinar on creating a geological model for free. So you can find the link on our website, or you can scan this QR code now. And when you define the type of planimetry quantity, you must select the material, which if you click on settings button next to the drop-down menu, a list of all materials will open. You can then edit the existing quantities or add new ones, and these quantities are written in the PLI file, which you can also copy and share with co-workers. Okay, but after the selecting material, you define additional settings in the bottom part of the dialog box. So we have three options available. The first option is the inner point. In this case, you first select the line that represents the edge and then select any point inside the planimetry polygon area. The second option is between two polylines. Using this method, you define two polygon lines bordering a surface you want to planimetry. If you select under reference polyline, you first click on the upper edge of the material, press enter, and then click on the remaining lines, which represent the boundary of the polygon. If you select under reference polyline, always be sure to click lines in a counterclockwise direction. Okay, so let's go back to the drawing and select the inner point option. First, I select the line that represents the edge, and then I select any point inside the planimetry polygon area. Then I run the planimetry command again to planimetry the lower part of the curve. However, this time I choose a different option. So now I select the bottom line, click enter, and then I click on others. Okay. Then I continue drawing other typical cross-section elements. So I will now create a sidewalk. So I define a name, check, so in this case, a sidewalk, and then check the box at the from selected point option. Okay, and then I have to select the element to which the line will be attached. I also have the option to edit each typical cross-section element. So you saw that after running the edit command in the drawing, I select the element and its dialog box opens where I can change the data. Okay, but this time I want to draw this element in a 3D, so I need to give it a certain thickness. So I run this payment command again and select material. Then I proceed with the shoulder element. So, and after that, I draw the embankment. And then I repeat the same procedure on the left side. So first I will insert the curb,
this time on the left. So that's why the minus. Then the sidewalk. Okay, and the last element is the embankment. Okay, and finally, I will also draw the substructure. Here it's important that I check the box next to the draw to embankment option. That means that the commands will automatically trim the lines. Okay, but since we don't have time to draw all the elements together today, I will run a macro. Macro is essentially a library of typical cross sections that you can create yourself and then use those cross sections in any project you want. Okay. And now you can see that we have all the cross sections finished, and we can continue with creating a quantity takeoff report and a 3D model. So you run the quantity takeoff command, and in the middle part, you can define how the quantities should be shown on profiles. So you can check the insert in drawing option and then select the location for planimetry labels. You also have the option to save them into external file. In the lower part, there is an option to insert a summary of quantities in the drawing. So check the box and then define the location of the table. Okay, then press OK, and the quantities are displayed in each individual cross section. So if you zoom in on one cross section, you can see the name of the quantities and their values. And at the same time, a table with a summary of quantities is also inserted in the drawing. Okay, so after completing all the cross sections, you can create a 3D model. However, since we want to make a BIM model, we will first define property sets. These property sets are like metadata that is attached to elements and are the key component that separates a BIM model from a 3D model. In CGS Labs software solutions, the user has two options. So automatic attributes whose values are calculated and inserted automatically after drawing a model with the draw 3D model command, and attributes that are defined and attached manually. So now let's take a look at the process of editing property sets. So to add, click on the plus button and define the name of the property set. Okay, then click on the plus button on the right to add attributes. So define a name and then select a property type. So if you choose the user defined option, it means that you will have to enter the attribute values manually. We enter the default value in cases where we know that it will always be the same, for example, the material, or in cases where we will enter the value manually using the property set editor command. If you choose one of the other options for property type, the program will automatically insert the value of the attribute after we run the draw 3D model command. And all those informations about which attributes you need to attach to an individual model can be found in the BIM execution plans. Okay. Okay, so once again, click on the plus button, define the attribute name. So in this case, start station. We want that start station is calculated automatically. So we select this value from the drop-down menu. And then I repeat the procedure for the and station. Okay, and once you have defined all the property sets, you can continue with drawing a BIM model. So after running the draw 3D model command, define the source data, alignment, and select quantities. Then check the box at the Align option to connect the consecutive planimetry polygons along the alignment. Otherwise, it connects the adjacent planimetry polygons with sectional straight lines. Then you define the corresponding property set for each quantity. For example, the surface course property set for the pavement. So, okay. And then, for example, shoulder, okay, and my property set is also called the same. Okay, and then click OK, and a BIM model is now inserted in the drawing, which is basically a 3D model with attached information. So I will now just zoom in a bit on this model and hide the raster image so that you can see the model better. Okay, so now we have a BIM model, and then we can use a tool called Property Set Editor, and we can check whether the property sets have really been attached to the model. I run this property set editor, and then I simply select the element in the drawing, and attached attributes will be shown in the dialog box. Okay. And here you can also add more property sets. For example, I will add a property set with project data to all surface course elements, and I can also type new or edit existing values of attributes. Okay. And you can also see that the axis name and station have been entered automatically. Okay, and once you have the entire model, entire BIM model and equipped with attributes, you can export model to IFC, and then there you can create different 4D and 5D simulations, also visualizations of constructions of the construction, and other renders, for example. So, okay, we have now gone through a typical workflow. So to quickly repeat, the key workflow steps in the Plateia program are digital terrain modeling, then creating alignment design, creating profiles and calculating super elevations, creating cross sections and typical elements. And if we want to create a BIM model, it is important that we also planimetry typical cross-section elements. So I hope that today's presentation has provided you with a general understanding of how to design using the Plateia program. In addition to a wide range of tools for designing new roads, Plateia also provides powerful tools for reconstructions. The reconstruction process usually starts with the insertion of geodetic points. Then using the best fit method, we can automatically draw the alignment to obtain the best approximation of main elements through the desired points. And afterwards, we can proceed to create sample lines. And as part of the reconstruction tools, there is a functionality that automatically generates sample lines based on recorded points, and the alignment can be projected directly onto these points without the need to create a digital terrain model. The design process continues with the profile, which can also be automatically drawn and adjusted according to input data. And moreover, there are tools available to convert 3D polylines to super elevation. We then draw cross sections, and if needed, we can create a BIM model in the same way as we have shown today. Unfortunately, we could not go into further detail today, but if you are interested, you can freely watch our previous webinar on reconstructions, which is available on our website. Besides, we have other platforms such as CGS Labs knowledge base, blog, and YouTube, where you can find tutorials that can assist you in your work. We strive to regularly prepare content that can be beneficial for you. At this point, I would like to thank you for your attention, and now I will hand the floor back to Gregor.
Thank you, Petra, for these excellent presentations. Just let me switch back to my screen. Just a second. Okay. So I hope that you enjoyed this very nice technical presentation. Now I'm just going to share a few more information with you, mostly for those who don't know our software yet. It's a good information that we have free 14-day trial of every CGS Labs software available. We're talking about fully functional, no limitations, technical limitations trial. So what you need to do is to let us know that you would like to try the software. You can either write us an email or go to our webpage, visit, for example, Plateia product page, and you can apply for a free trial of the software on the web page. During the trial, there are several options available that can assist you. First, we have free basic online training. This is elementary online training, which is supported with PDFs, working documents, DVGs, and videos. And if you go through this online training, you can have a better trial experience. Of course, we're also offering you access to 24/7 CGS Labs knowledge base. This is accessible through our webpage. It contains all the tutorials that you would need for installing the software, and then a comprehensive user manuals for the software, and there are several text and video tutorials available for different features of the software. And maybe most important is also that we provide a live customer support to all our users. This means that on the other end, you will be talking to a competent civil engineer that can answer your question, that can suggest good solutions for your issues on the projects. And this is also available not only to the customers who are on either subscription or maintenance of the software, but also during your software trial period. Now, I would like to just check if we have any questions, because I noticed that you were writing some questions that we could answer. Yeah, one of our users posted very interesting questions, but unfortunately they are written in local language, so we can't answer those. Let me just check if...
Yes, Gregor, many questions are not in English, but we will answer them by email, yes, after this webinar.
Okay, is there any question that we answer now, or we just wrap everything in the email, Petra?
I think that we can wrap in the email.
Okay.
Yes.
Okay, so Petra already mentioned lots of our resources. When you can find some additional information, I would maybe emphasize this our page for the webinars, because we are producing a lot of on-topic webinars. For example, she mentioned reconstructions, but there were also some very interesting webinars in the past for the road designers. These are all available on this page, go to stage, and you can access this go to stage page, of course, from our web pages. You can just scroll down to the bottom of the page and you will see the link to the webinars, and click the link. And we have the webinars prepared also in some local languages, for example, in German, in Serbian, Slovenian, English, Czech language. So whatever is best for you, you can take advantage of. And also, I encourage you to apply for our blog, because this blog covers some very interesting posts from the presentation of the projects, how, for example, civil engineers use our software to solve some issues on the projects. And we're also presenting some how to use certain features in the software, tips and tricks, and other useful stuff. There's also our YouTube channel, where you can always find some useful videos, get started videos that can help you start with the software or address the use of certain features in the software. And we're also sharing, of course, all our materials through LinkedIn. So if you connect to our LinkedIn channel, you won't need to worry to get informed whenever we produce any new material. So this is also one very valuable resource for you. So I think this wraps up today's webinar. We're both very grateful for your attention. We hope that the webinar was useful, informative, and that you lastly enjoyed our company, and hope to see you soon on one of our next webinars, and we'll keep in touch. Thank you and goodbye.